So for instance, if I take this pen and I try to balance it like this, then I can say that this point here is the center of gravity for this particular pen. Hey learners, this is Dr. Rishi from the Learners Academy, and today we are going to go ahead with the next part in our 10th ICSE chapter 1, that is force. Today we are going to discuss about center of gravity and uniform circular motion. So first, let us have a small recap about what we did in the previous chapter. The previous chapter we talked about the force, the formula for the force. The formula for the force, so I write the formula for the force. Force was equal to F is equal to ma. We also had a formula for torque. Torque was the force multiplied by the distance between the 2 points. So this was the torque for the couple. If it was a single force, then it would be force multiplied by the perpendicular distance between where the force is applied and the axis of rotation. So now let us go ahead and talk about center of gravity. Now we've heard about this word a lot of times. However, we need to understand what it basically means. In simple terms, center of gravity is the point on the body or inside the body or at times even outside the body where the total mass of the body it can be considered to be applied. So it is the point at which the gravity is applicable. So for instance, if I take this pen and I try to balance it like this, then I can say that this point here is the center of gravity for this particular pen. Now as the shape of the body would change, obviously the center of gravity would also change. So let us go ahead and see what happens when we take a random shape and we try to find the center of gravity of that random body. So here in front of me, I have a piece of a shape that is there, which is randomly cut. Now I intentionally cut it in a random manner so that I can demonstrate how I can find the center of gravity for this particular shape. Now if I can find it for this particular shape, then I can apply similar tricks to find it on a regular images that we have or regular shapes that we have. So for instance, a circle or a square or a rectangle or a triangle. So let us see how we can find the center of gravity for this particular piece of paper. It has a very random shape. So let us go ahead and see. So there are a few things that I am going to need for doing this particular experiment of finding the center of gravity. The first thing I am taking is a pin, and I have this piece. So I will insert the pin here. So now what we have here is we've taken a rope, we've hung a bob to it like this, and we are going to use this rope to find the line that would be drawn. So if I hang this like this, and if I am hanging it, it would give me a particular, at this particular point, I would get a second point here. So I will quickly mark this point. Now we have marked the first point here. Now I will put this rope in another position and draw the second line. So I need 2 points to draw the line. So my first point I will mark up here where I have the pin located, and this is my second mark. Now I will use another direction to hang the shape one more time and get the second point. So again I use the pin. So this is my first mark, so I will try to hang it sideways like this. So here I have hung it sideways like this. So now I need the second line that would be there. So I will be hanging the rope one more time like this, it would give me the second point or the second line. I need 3 such lines so that wherever they would coincide, that should be my center of gravity. So this is my second point, I'll quickly mark it. And same way I'll take third point, so let us maybe take the third point here somewhere. And if I hang the rope one more time in this direction, we'll get a third point here somewhere. So I'll just mark it. I have effectively got 3 lines. So let me quickly draw these 3 lines and show it to you. I have drawn these 3 lines that we had plotted using the thread, and if you can see this small triangle that is formed, it is going to be the center of gravity for this particular shape. So if I put my finger on this center and I try to balance it, you'll see that the shape would balance completely at that point, which basically means that we can consider the mass of this entire shape at this particular point. So if you see, I can easily, no matter what I do, it can be pretty easily balanced at that point. So this is how we can find the center of gravity of any random body. Now, so let's talk about some regular shapes. So the first shape that comes in our mind would be a triangle. So if I have a triangle like this, then it would be basically the point at which all the 3 medians of the triangle would meet. That would be considered as the center of the gravity of the triangle. Now, I have drawn an equilateral triangle. If it's an isosceles or a scalene, obviously it would shift. It won't be exactly at the center, it would be slightly in a different manner. Now, if it's a circle, it is going to be at the center of the circle. The center of mass would be at the center of the circle. If it's going to be a rectangle, then it would be basically the point at which both the diagonals meet. Here, if it's a square, again it would be basically where the diagonals meet. So is with parallelograms and rhombuses. Now let us go ahead and look at certain things where the center of gravity is not actually inside the body. It means the center of gravity would lie outside the body. Okay, so if you see this setup where we have 2 dolphins like this is a classic example where the center of gravity is outside the body. So if you see, this is the center of gravity for this setup of 2 dolphins, and if I put them in motion, you see that their mass would be acting at these points only. So we can set them in motion like this and they would undergo an oscillatory motion. The other example for the center of mass not being on the body is a ring. So for a ring, the center of gravity is going to be this point, which is at the center of the ring. So I can hold it like this and I can turn the ring like this. I've made an arrangement for it so that I can actually twist it. Okay. However, if it's a solid circle like this, then the center of mass would be at the center. So you can see that I can easily balance it at the circle, at the center, and I can actually turn it very easily. If we've already seen it for a rod, what happens for a rod or a cylinder, it would be at the center if the rod is held like this. If the rod is held vertically like this or a cylinder is held vertically like this, then it would be at the center of this circle of the base. So these are the points where we find the center of gravity of various shapes that are there. So learners, that was it about the center of gravity of a body. This is how we are going to find the center of gravity. If you found this video helpful, please give us a thumbs up. Please subscribe to our channel and share it with your friends. This was Dr. Rishi from the Learners Academy. Thank you.